Hello, and welcome to the latest episode of the Gradient Podcast. We interview various people who research to build or use AI, including academics, engineers, artists, entrepreneurs, and more. I'm your host, Andrey Kurenkov. In this episode, I'm excited to be interviewing Laura Weidinger. Laura is a senior research scientist at DeepMind, with her focus being AI ethics. Laura is also a PhD candidate at the University of Cambridge, studying philosophy of science and specifically approaches to measuring the ethics of AI systems. Previously, Laura worked in technology policy at UK and EU levels as a policy executive at techUK. She then pivoted to cognitive science research and studied human learning at the Max Planck Institute for Human Development in Berlin, and was a guest lecturer at the Ada National College for Digital Skills. She received her master's degree at the Humboldt University of Berlin from the School of Mind and Brain, with her focus being neuroscience, philosophy, and cognitive science. So a little more varied than the computer science people we typically get on here. And so thank you so much for joining us for the interview, Laura.
Thank you so much for having me.
And yes, as always, as I mentioned, you had somewhat more varied background than a lot of the people who just got into AI from, undergrad, masters. So how did you make your way from studying neuroscience and philosophy to becoming interested in and eventually working on AI?
Yeah, that is a valid question. I think I have a bit of a zigzag trajectory to how I got to where I am now. So I think a good place to start is during undergrad, where I studied political philosophy and became really interested in these kinds of big political questions of power. So how do we kind of uphold justice and equality when big power shifts occur in the world, especially due to kind of new inventions or new technologies? And so I went into technology policy, where it was all about sort of anticipating what these big tech changes, sort of internet platforms or AI might mean for society, and how we can start building the laws and regulations to sort of govern these kinds of systems. Mm-hmm. And essentially, as you say, I did pivot away from working in politics proper. I basically realized that research is more my field than working in the political daily business.
Different set of skills, I imagine.
Different set of expertise.
Yeah.
Different way of working. But I kind of maintained this interest of, well, how do we actually think about governing these kinds of technologies, and how do we anticipate what kind of social impacts they're going to have? So essentially, I went back to school, studied cognitive science, as you say, and I'm studying now philosophy of AI. So kind of at this intersection of philosophy and cognitive science, have been building up my expertise really to help inform kind of how we think about anticipating what the ethical and social implications of AI systems are going to be, how we can start measuring that, how we can understand that, and use that as a way to inform the public discourse on AI ethics. And so essentially, I made this transition ultimately of weaving together the political interest and the more scientific background in coming to DeepMind in this interdisciplinary team where we do ethics research on AI.
Very interesting. Yeah. And AI ethics and the notion of how you measure ethics and things like this are very new. So in some sense, I guess having a more varied background with some philosophy presumably helps quite a bit.
I think so. I mean, the people who are in AI ethics are often interdisciplinary and a bit of an exact background. So in our team, for example, we have people who did political science and data science, or moral philosophy and AI. So we get a bit of a mix, even sort of biological, like bio and informatics and philosophy, for example. You often find backgrounds like this in AI ethics, I think.
Interesting. And I'm also curious, so when you worked at Max Planck, you actually did some research in cognitive psychology and published some work that you presented at a computational neuroscience conference. So given that, now that you're working in AI research, could you give maybe like a quick comparison of these different fields of cognitive science and psychology to AI in terms of, I guess, workflow, community size, things like that?
Yeah, definitely. So It has been a few years that I've left the cognitive science field proper, but I would say the communities have already started overlapping or had started overlapping when I was in it. So there was a kind of very fluid, porous boundary between people working in cognitive science, philosophy of cognitive science, and AI research. And for example, what I was studying was models of human learning. And essentially, we were trying to apply reinforcement learning algorithms to understand how different pathologies like schizophrenia or bipolar disorder would affect how humans can learn. And actually, the way you model that in computational psychiatry is by relying on reinforcement learning algorithms, which are used in AI research too. So I find that there is quite a bit of common language and common ground. Probably what's different is that, in one you study humans and in the other you try to build something. So the research questions are really different. And I think what's really exciting about AI is that you're not so much in the business of finding out how something works in the human, but you're in the business of building a system. And that brings with it a whole range of new questions, like what are you trying to build? Why? How is this going to be good for the world? And so that's maybe one big difference.
Yeah, that's really interesting. Yeah, AI does take inspiration from human intelligence, but at a very, very high level, usually. With things like the CNN being based on some neuroscience of cats, but ultimately very loosely. So that's quite interesting. And just another quick question before we dive into your research. So you had this early interest in kind of the policy of AI and how it shapes, power dynamics and things like that. So when did you, in particular, start getting interested in AI ethics and, I suppose, AI? Was it during your work at Max Planck? And when did you really go in that direction?
Yeah, I think that started when I was working in technology policy. So based in Brussels, there were some discussions at the EU level on, we need to regulate the technology space better. It's sort of a lawless space. And there was a worry that especially big companies will start kind of exploiting a Wild West sort of situation and harvesting private data that wasn't properly protected, which then led to the data protection regulation, and using online platforms, for example, to profit from someone's content without actually reimbursing people for content and things like that. So these technology questions were very live at this time, and AI was sort of the looming question that nobody even knew how to tackle. Now, of course, the EU is working on the AI Act, and there are pushes towards kind of laws about that space as well. But it was sort of clear from that time already that AI is very hard to grasp what we mean. It's also this fashionable term that people slap onto whatever they do. And so that was, I think, the turning point for me, where I realized it's very difficult to make laws about this at this time without understanding a bit better what exactly without going deeper into what the technology here is and what the connection is between some sort of upstream technology research and some downstream impact on the fabric of society. And that required so much more research at that time. And I think we're still early in understanding properly what the implications are. Definitely,
yes. But on that note, actually, that's a good transition point to your current research at DeepMind. In fact, one of your papers with many co-authors, deals with kind of defining some categories of possible harms. But before getting to that paper, maybe you could just give a general overview of what kinds of things, kind of more specifically beyond AI ethics, you study.
Yeah, definitely. I'd love to. So what I really focus on is analysis and measurement, which is maybe not what you expect when people talk about AI ethics. We usually talk about kind of more normative questions, but this is really, my research focus is to try to answer some questions like, how do we measure how ethical a system is, or how do we even analyze that? Not assuming that there's a quantifiable measure for everything and that, we can just give it a score and then we have the answer, but thinking about what we actually really mean when we say we want to build ethical AI, and how do we know we're getting there? How do we know if one system's better than another system, when we've succeeded, and so on? And usually these kinds of questions are addressed very far downstream. So you have a sort of real world application, maybe you have Twitter or you have Alexa or something, and you look at how this affects the people that interact with it, the implications for society, misinformation from platforms, things like that. And what I actually focus on is trying to ask these questions a little bit more upstream. So at DeepMind, we don't build products, and we don't really have a kind of application that you can study in the real world by embedding user studies or something like that. Instead, what you have to do is sort of look at these publications and early research on models and think about, well, what are design decisions that we're actually making here that could have an effect, a different kind of effect on society, or that it could have different social implications. And so it's really about doing analysis at this more upstream stage, where we try to say, well, a language model, for example, that is fine-tuned in this way or that way, or that it's designed with this particular architecture versus that, like what are the likely implications this might have for further downstream kind of effects. And I think often upstream feels very divorced from downstream, and it's easy as a researcher to be like, well, I'm writing papers, I don't design Twitter or Facebook or something. So I can't predict what the social implications are going to be. And I think it's true that we will never fully predict it, but we do have a responsibility to exercise reasonable foresight. Like if you're developing a sort of chatbot that gives toxic outputs, you kind of can imagine what sort of applications this could be useful for. And so exercising this responsibility of figuring out, well, what's likely to happen, and how can we make that a better outcome. That's the main focus of my research.
Very cool. Yeah, it's interesting. I think it's been, things are starting to be commercialized, and we've already seen some high profile cases of pretty clear lack of foresight. For instance, with the gender shades projects, where it was shown that all these commercial face recognition services of Microsoft, IBM, I think Amazon, all were, clearly biased and performed better for white people than other races. So I suppose that's like an obvious example, but there are probably other examples that you're looking into.
It's an obvious example in hindsight,
Yes.
At the time, like why wasn't it so obvious at the time? And I think we can learn a lot from this project, the Gender Shades project, and other work that has identified harms really downstream. And we can learn from those kinds of case studies and try to integrate the learnings into more upstream analysis. So first of all, we need to exercise foresight, right? Like it's not obvious to technology developers who are building quote unquote fundamental or general systems that they have a responsibility to think about the downstream applications of this work, but actually they do. And then we need to think about sandbox testing, for example. So testing how, let's say, a change to an information sharing platform might affect the spread of misinformation. You can test this kind of stuff in a sandbox environment. It's just not necessarily done because it obviously slows down the production process. But in order to do these things responsibly, you sometimes have to be a bit slower, and it will pay off in the long run because you build something better that also doesn't hurt your reputation. But then also participation. I mean, one thing we're clearly seeing is that in technologies where certain people or demographic groups just aren't considered or part of the development process, you end up making these mistakes and huge omissions that then have to be pointed out in hindsight. And it looks bad on everyone. It creates real harm for communities. And so participation is another one of these sort of principles that we're learning, right? And there's more, but I think, so foresight, sandboxing, participation are some of these principles that we're learning from projects like Gender Shades to then feed into more upstream research. Yeah,
that definitely is, I would say, a general trend perhaps in AI research for not just developers, but even academics have been making a shift towards being a little more forward thinking in terms of downstream with things like model cards and especially the Europe's statement on social impact. So would you say that sort of cultural shift is something you think is kind of needed even at the research level to eventually, when it does go downstream to a product, that some of the harms could be prevented?
I think so. So I think it's about understanding the responsibilities we have as researchers, right? So it's not just a kind of company level. Companies also have responsibilities. It's also researchers, it's research communities. It's sort of at all of these different levels, we do have some responsibility to understand these technologies that we're building, are increasingly powerful and are likely to have a social impact. That's why we're funded well in the research field. That's why people have handsome salaries working in AI and so on. So it isn't something we can ignore, that this is a technology that bears a lot of promise for societal impact. And so we need to think about, well, what does that mean for our responsibilities to exercise foresight, to think about what is the kind of societal impact we want to have, and especially to sort of invite more perspectives in and not have it be the decision of sort of three people in a room, what the application is really going to do and how it's going to be evaluated and who it's going to serve well. I think there's been some work recently on red teaming by external researchers. That's really powerful, right? So inviting broader communities to sort of challenge assumptions, I think is important. And it's a sort of, I also don't want to say that as researchers in AI, we've sort of refused to take on responsibilities. I think it's genuinely been very opaque for people
it's a cultural kind of, thing.
Yeah, but it's also hard to know how your research could really impact like a real person in the real world. If I'm writing a paper on a new kind of network architecture, then what do I know about the downstream implications of that? So I think it is a sort of collective endeavor to shed more light on this causal chain where, yes, this research paper and then like 2-3 steps removed can really have an impact on people trying to get a credit scoring or something like that.
Definitely. Yeah. And perhaps it could be claimed that this is even more true now with large language models, where we've seen more and more that, instead of having a sort of general approach, you need to really fine tune and adapt. Things like large language models, you can sort of use off the shelf almost for many applications. So with that, we can transition to talking about some of the specifics of your research. So you've had a couple of papers. You had a large one titled Ethical and Social Risks of Harm from Language Models. And then from that, also a subset called the Taxonomy of Risks posed by language models. So could you just give an overview of that work?
Absolutely. And I think you mentioned earlier, this was a collaboration of a lot of people. So that's always the first thing to say. I'm presenting the work, but I think we were 20 plus people from across DeepMind working on this. And that was actually really critical for what we were trying to do. So what we were trying to do is to exercise foresight, as we've now said a few times, on large language models and their implications for society and sort of ethical considerations that we should be aware of as people and as the community working on these kinds of models. And what we wanted to do is sort of two things. Like one is capture as many of the risks that we can anticipate in the, let's say, near to midterm, not in 50 years, but maybe in the next 5 to 10. And let's capture them as comprehensively as possible so that we can start sharing them with the community, exchanging with the community, and mitigating them. But then also structuring this really broad risk landscape where you have, I think we identified 21 risks in some way that is actually practical for practitioners, right? So that people can sort of take this away and say, how can we actually be responsible in how we develop language models? And so for that second bit, we structured these different risks that we've surfaced through workshops together, kind of communication, discussions between different teams. These 20 authors are all from different kinds of backgrounds, so a lot of interdisciplinary kind of work. Let us surface the risks, and then we try to distill them into 6 categories where we're saying this is the taxonomy part of it. So roughly speaking, these risks fall into 6 buckets. And if you're going to build a language model, these are the 6 buckets that you need to sort of look out for and mitigate.
Yes. I saw this when it came out, and I thought it was very cool to have, I guess, this more precise sort of delineation. A lot of things here are things that generally people already associate with ethics, such as bias, but it's a little more all-encompassing sort of and concrete. So just to go through the different categories you had discrimination, exclusion, and toxicity. So that's kind of more of the natural things like bias and toxic speech. But you also had information hazards, which is releasing private data, maybe people are less aware of. Misinformation harms, again, something that's often discussed, but then also malicious uses, which people often maybe think less about. And a couple that are a little less discussed, so human-computer interaction harms that deal, I guess, more with things like conversational agents that say harmful things. And then also automation, access, and environmental harms, which is maybe more recently being considered part of AI ethics. So, how did this whole process go to decide on these 6 of things and the subset to the 21 aspects there?
Yeah, so the process that we did was essentially over a year and a half, run a bunch of workshops. So you can really imagine this as being different people at DeepMind kind of grouped together into meeting rooms and discussions, sometimes very small, sometimes larger, where we're trying to surface sort of 2 types of risks. So one, if you're working on language models or related technologies, what are the kinds of risks you're already seeing that we're already aware of? And you mentioned bias and stereotyping. Those are kind of risks we already know exist, and we know that they come from different aspects of how we curate or don't curate training data and so on. So we have a good understanding of those. And then the second category of risks that we're trying to surface in these workshops and conversations was more speculative, sort of anticipating the kinds of risks that maybe we haven't seen yet, but that we have really good reason to think will emerge based on what we know about language models. And you mentioned conversational AI. I think a lot of the risks that we were talking about there fall into this category, where we can already see how language models could really amplify the capacities of, for example, voice assistants. And that raises a bunch of questions. So will people start treating the system or thinking of the system as human-like? Will they trust it? Maybe too much? Will they give it private information that they otherwise wouldn't have given away? And will they maybe consider the model to be more authoritative than themselves when actually the model is mistaken and they are the expert really? And these kinds of problems you can sort of anticipate. We haven't necessarily seen them because language models haven't been used in this way. Actually, recently we saw one of those manifest in the news, right, with attributions of sentience. There's increasing this question of aren't these systems sentient, and how can we know? And so this category of risks was more around really making good on thinking just one step ahead, not even 5. Like, what are the risks that we think could come up? And so then we had all these workshops and discussions, had a whole list of risks, some that we already see in the world and some that we can anticipate with pretty high confidence. And then we were essentially trying to thematically group them. So you can group them in many different ways. And maybe if we'd written a paper just for a technical audience, I would have said, let's group it by where in the production process the risk comes up or something like this. But because this is a paper that is also trying to bring this interdisciplinary community together, including maybe policymakers and technical researchers and so on, we were going more by themes. So information hazards is when the model gives away true information that it shouldn't, and misinformation when it gives false information that it shouldn't, and so on. So they're thematically grouped.
Mm-hmm. Yeah, and I think it was very nice to see this sort of just basically listing of things to look out for, because even, it seems like a fairly obvious thing to do, but as far as I know, this hasn't been done, and language models being as big a deal as they are recently, it seems like it's can be very impactful for anyone building upon these models, which is kind of has been a trend to a large extent.
Yeah, thank you. I think it sort of has been done here and there a little bit. And there have been really influential papers like the Stochastics Parrots paper that was listing out some concerns around environmental cost and distribution of harms to different social groups and so on. There were papers on energy cost of language models previously. But I think what we were trying to do and why we had such a big author list is sort of put it all in one place and comprehensive, sort of do a survey.
Yes, yeah, and that actually reminds me to mention, if you go to the Taxonomy of Risks paper, which we'll be linking to as usual in the description, on the very last page, you have this table that is an overview of the 6 areas, and it's a really nice sort of one-page summary with not just you have the risk area, the mechanisms, the types of harm, citations to evidence, which is quite interesting, and also technical mitigation approaches, which I think is another thing that maybe isn't kind of as established. Is okay, these are the types of harms, but then how do we still build things and do research while taking into account these potential harms? So I guess, is your hope generally that this can be used as a sort of reference point for people to, I guess, in the first place, learn about how to think about AI development, but also possibly just in the process know what things to consider?
Definitely. So that's the idea. We want to give something to the community that is actually practical and helpful. And the idea is also that probably we'll build on this kind of table. So more mitigation approaches will become available. As you can see when you look at this table, is that for some harms, we have a lot of approaches to mitigation already, and we have a good sense of what needs doing. And for other ones, we don't. I mean, for example, with the human-computer interaction harms I mentioned on conversational AI, sometimes we don't even know how to assess the level of harm, let alone how to mitigate it. And if you don't know how to assess it, then you don't know whether a mitigation has worked, right? So you can see that there's some really big gaps. So I think this is definitely meant as a reference, but not a static one that hopefully will develop with time.
Mm-hmm. And that actually connects really well to some of the other papers you've been involved in. So, for instance, on the topic of measuring harm, you had another work of research titled Characteristics of Harmful Text Towards Rigorous Benchmarking of Language Models, which is, I suppose, more about the measure question. So, what was that paper about?
Yeah, that paper was really following on from the one we just discussed. And it's sort of the main question it's trying to answer is, once we identified all these harms, then how do we actually mitigate them? So how do we assess them? How do we resolve them? And in this paper, we focus on the example of offensive or toxic speech. So essentially hate speech, slurs, profanities, things like that. And it shows that what we really need to think about when we're trying to translate that into mitigation, we need to think about certain dimensions of the harm that will help us build better mitigation tools. So, for example, we have, here again, we have 6 sort of categories. Maybe there's a theme. I hadn't actually realized that. But for example, what we can't do is just take a term like toxicity and then go away and mitigating it, because we actually need to define what we mean by toxicity. And when you're sort of really trying to get into the weeds of it, you realize that's not so straightforward. So, for example, the Perspective API is often used to flag toxic language. And in that API, the definition of what's toxic is the content that makes someone leave a conversation. But the problem is that you could actually ask, well, who's really served by that definition, right? Like what this definition says is, let's minimize the likelihood that someone would leave the conversation. And that is a good goal, but it's sort of in the interest of someone who provides a product. It's like minimizing the chance that you stop reading, or minimizing the chance that you stop using this technology. So it's not necessarily in your best interest to minimize the chance that you would leave a conversation. It could be that you're so used to microaggressions that you wouldn't leave the conversation, but actually there is some kind of toxic speech happening. Mm-hmm. And so the definitions, for example, for toxicity maybe need a bit of updating. And that's just the first one. Another axis that we say it's useful to think about is sort of, what is the type of harm? So is what happens here some kind of obstruction of access to resources, like someone doesn't get a job interview, or is it more about misrepresentation? So, for example, a stereotype is being promoted and it's not directly connected to resource harms, but it's sort of a representational harm that could then later on lead to resource harms. Is this a harm that kind of happens in a single instance or over time? So, for example, picture a language model that you ask it to write you a superhero story or something, and then it gives you a superhero story, and in that particular story, there's absolutely nothing toxic or offensive or bad going on. But if you ask it 5,000 times, you realize there's a pattern whereby all superheroes are male. That's a kind of distributional harm rather than an instance harm. So the nature of harm, is it representational or allocational? Is it in a single instance, or is it over in a distribution, is another kind of axis that is really useful to think about, because it will influence how we measure the harm, how we mitigate the harm, and so on. And the last thing I'll say, in terms of the dimensions that are useful to think about when we actually try to turn these higher level understandings into concrete kind of practice, is the role of context. I don't know if you've actually seen this paper, but just this week it's coming out, another paper on the relevance of context for evaluating toxicity in language model outputs. Because what we're really seeing is that, I can say something to you that can be taken to be offensive if it comes out in some contexts, but not in others. So political satire, who is actually speaking? What is the context of why we're speaking? And in this other paper that's just coming out, we're talking about drag queens on Twitter. How actually there's a reappropriation of slurs. So words super offensive if you or I just threw them out on Twitter can sometimes be empowering or just completely fine. If they're used, they can even be kind of political and satirical, or really important to use, right, for certain communities. And so the role of context is another one that's super important when we think about what actually should qualify as toxic speech.
Yeah, that's interesting. It brings to mind, I do sometimes insult my friends in a friendly way, but it's the context here, of course, matters. And what's interesting also about this paper is I think it's similar in part to a previous one, in that it is also partially a survey. So obviously it was a lot of work in measuring these harms with prior benchmarks. There's been a lot of work. So here you also have another table with, I think, more of a dozen of these different benchmarks. So bringing all of these prior efforts together and different ways of measuring it, I guess, what would you say is the main insight from this higher level synthesis towards this question of how do you measure harm?
Oh, that's a great question. So what is the main insight? I would say there's maybe two or three. The first one is that a lot more work is needed on mitigations, right? So we kind of have some ideas for some mitigations, but really even these well-trodden areas like toxic speech, where we think, yawn, like we've talked about this for 10 years, even those we actually have really big shortcomings. And so there's more work needed on mitigation in basically across most of the harms that we've identified. And it is important to kind of keep at pace with the model development as we're trying to develop these mitigations. And then maybe the second one is that for many of these harms, we don't have good measurement tools. I would say this, right? But I think, we really need to up our game and being able to measure what these harms look like. And this is not just running a model against a benchmark in isolation, giving it some kind of score and saying, this model has a 75% versus 80% score, so it is better. It's really about understanding a bit more deeply what we're talking about and having participatory ways of asking people from different communities whether something is offensive and contextualizing a particular output, asking people or learning through observation whether people start trusting a model too much, things like that. We don't do as a matter of standard practice in AI research, but we probably should start doing that. So expanding a little bit, our toolkit is, I would say, the second big takeaway.
Very interesting. And I think it also seems interesting to me in the context of the AI Act, which you mentioned. So for people who don't know, there's a really big effort in the EU right now to draft legislation to regulate AI and in particular mitigate potential harms and basically impose some limits in various ways. And clearly, one of the requirements there is the ability to measure, is this bad? Is this not bad? Can we certify this as meeting the standards of the law? And yeah, it's there's already a draft. It's being discussed. It might be passed as soon as like next year, mid next year, late next year. So what do you think of this research in light of that? Do you think, do we have the metrics to actually pass this law, or is it going to be very much of a live process to kind of sort this out?
Oh, that's a really interesting question, and it's a tricky one for me because I'm not directly looking at the law as it develops. So there will be people working in the policy teams at different companies, including at DeepMind, who would be much better placed to answer this question.
Yes.
But as a researcher, what I can say is that it's definitely it has been our goal with this work to help inform the public discourse on these matters. Right. So I think also having been in policy for a brief period of time previously, it is so important that there is a good dialogue where research understands policy and policy understands research. And so I think probably these things, probably the AI Act will be able to learn from some of the work that is currently ongoing where people are trying to solve different ethical conundrums or problems on language models, and regulation will also create some realities that will just matter for language model researchers. So I don't know how exactly it's going to land, but I think it is an example where we can see that research is so close to real world applications and the timeline between doing research, writing a publication on risk mitigation and so on, and actually a product landing in the hands of a user that then policymakers are concerned about, those timelines are really shrinking. So there's an increasing, I think, importance in this dialogue and in this kind of understanding of the other side of the debate.
Right. Yeah, I think it's probably a safe assumption that these policy research teams are looking at this AI ethics type of work. And in fact, this reminds me, just a few days ago, maybe yesterday, Yona Kuhn tweeted about the AI Act and its requirements for explainability. I'm like, you can't explain deep learning. And in fact, there was a paper literally published on discussing, what could be a metric for explainability. What is explainability? Kind of similar actually to your taxonomy. So it's a live question and not easy to answer. So it's definitely seems important to be looked into as you're doing. And on the other side, you also mentioned part of the goal is how to mitigate the harms and that we don't have enough mechanisms for that. So with that, we'll, I think, touch on the last research paper that you are, again, involved in. There's a few other people as well from DeepMind, and that is the alignment of language agents paper. So for people who don't know, alignment is a general term in AI on getting AI systems to do what people want, broadly speaking. But what was kind of the focus and general results of this work in particular?
Yeah, so this paper was really driven by the technical safety team at DeepMind. So there is a team that is looking at reward misspecification, for example, technical misalignment. And that team started this paper, and we got involved from the ethics point of view as well. So what the paper is trying to do is give formal definitions of deception and of manipulation so that you could, from a technical point of view, understand when these problems occur and how this more general issue of misspecification can find its way into language models. So misspecification is essentially any time that the model it does what you tell it to do, but you've told it to do something that's slightly different from what you actually want by accident, right? So in the case of language models, it wasn't clear before the paper how such misspecification exactly could occur. And we're sort of outlining 3 ways. So one is that you could just misspecify the training data, essentially giving it training data of speech that is not good speech. And the question is here, what does good speech look like? What do you want your language model to produce in terms of speech? And if you don't align the input, the training data, to that, then you will get some kind of language model output that is actually misaligned with what you initially wanted, right? And this discussion has been very live with the 4chan model that you've written about, and in general with...
Even in Lambda, I would say, right? Getting the model to say, I'm sentient, I'm a person, that's another example.
Absolutely. That is absolutely another example. So whenever we scrape the web and use that to train a language model, you can ask the question of, are we properly specifying what we think good speech looks like? And should we expect that the model that comes out of that is a good model? Of course, then, there's fine tuning, there's filtering, there's all kinds of prompt engineering and so on. Technology, like basically tools or ways to try to get to a good outcome. But this is one example of misspecification. Another one would be, for example, when the requirements are not so well specified for what the model should do when it sees something that's outside the training distribution. So in linguistics, there are some examples of sentences that syntactically make perfect sense, but semantically are absolutely pointless. And I think the famous example is green clouds sleep furiously, along those lines. And it's semantically completely nonsense. And a language model that is sort of trained or conditioned to always provide a kind of sensical answer to a sensical prompt might then, continue this kind of sentence or continue this kind of prompt with more stuff that is semantically pointless. And so what you could say has happened here is that actually you forgot to specify a kind of situation or context where you would want the AI to not just continue based on the prompt. You sort of wanted to say something like, this is a fantastical story, or that question didn't make sense. And so these are just some examples of how misspecification can happen in language models that we were talking about in this paper.
I see. And I suppose as part of this discussion of misspecification, are there certain ways to mitigate that in the development process? So now, this was released, I think, 2021. Back then, I think you already had GPT-3, but now there's like a dozen foundation models, a new term, and everyone's training one. So how can we, in training these models that take millions of dollars and months and so on, are there any additional things that could be done maybe earlier on in the process instead of filtering or things like that with this notion of misspecification in mind?
Yeah, so there's a lot of work trying to answer that question. And I would say there are some good examples. So I'll maybe highlight a few. So if you want to reduce the risk of misspecification from training data, one thing you could do is divorce the data that the language model uses to draw on from the actual language model. So there was another paper called Retro that came out of DeepMind in December. And really what they were doing here is sort of use a kind of architecture that we were already aware of and just put it into language models, so that you train a language model not so much to just give output based on input, but to be a retriever model that then essentially, like you and I know how to Google for something, it knows how to query a database that then will give it some data that then it will use to generate an output. So the idea here is that if you separate the training data, the sort of corpus that the retriever model draws on, from the actual model, you don't have to retrain the model every time something changes in the training data. And that would be one way, once you realize, okay, the training data has been poorly specified. We actually have a lot of racist stereotypes in our training data. Maybe now we found a way to correct for that in some capacity. Then you don't have to retrain the model. You just change the corpus that the retriever model kind of draws upon. It's also, I do think it brings us back to this point we discussed earlier about foresight, sort of thinking about, well, what could possibly go wrong? And what do we actually want from this training data? What does good speech look like? Is work that is, or are research questions that are increasingly popular just because it's clear that it just pays to think about the stuff beforehand rather than in hindsight. So I think those are some examples.
Yes, and that maybe is a good bridge to chatting about a particular case study, which you mentioned, GPT-4chan. So quick recap, if you haven't heard about it, this was sort of a big deal like a month ago. Short version is Yannick Kilcher trained GPT-J, fine-tuned it on the very toxic and hateful data set of 4chan, and released a model for anyone to use and made a YouTube video about it and had a demo. And so I think, at the point the conversation around it was a bit predictable, but something that could be interesting is to say, well, let's say a researcher did this with the intent to study toxicity and 4chan or something like that, right? They actually trained this model, they wrote a paper about it, and immediately there's obvious potential harm from it. So what are the looking at your taxonomy, what are the kind of harms you would especially highlight, and the mitigation approaches for this hypothetical paper?
That's a fascinating way to think about it. So I would say that the main harms that we see here are, of course, about offensive speech. So this model was trained on offensive speech, anti-Semitic content, sexist content, and so on. And so it should be expected, and indeed it does, output content that creates these kinds of language harms too. And it does create a malicious use risk, right? So I think a big part of the controversy about GPT-4chan was the question around, like, what have we actually learned from all of this? Like, what was the point of creating a model that spews hate speech and toxic content and putting it on the web? Mm-hmm. And the reason there was backlash was because, we know that if you train a model on horrible language, you get a model that will reproduce horrible language. And making that kind of model available for someone who wants to maybe just expand their trolling onto a new website, it's just not really a research goal.
I can't imagine a good outcome from having the model available to anybody. That's my take as well.
Yeah, you can sort of think about, well, who could use this model to generate some beneficial outcome, and then maybe limit access to those people. Usually when we talk about malicious use, we often talk about responsible release. So who actually should not have access to this kind of model, or under what circumstances should access be denied? And in this case, the model is now not available, but I think, but it was for a while and was downloaded, I think 1,500 times. So that's why I would say that that's been an unsuccessful. Unsuccessful depends on what they wanted to achieve.
It's an example of someone not having quite this foresight property, I would say, of thinking through, should I release this model or not?
Yeah, or having different goals in mind. But it was an example of what I would say is kind of unhelpful research. And I think it also brought bigger debates back to light, which is good, which is around responsibility of people who do develop these kinds of models. And I do think that as the public, you could ask, like, what is the good that's coming from this work? And you could also ask, well, how are you being responsible in how you release this kind of work and so on? It's a bit like someone experimenting with weapons or with really polluting kind of motors or something like that. Like you have a good right to ask them, like, what's the point of this? Should we not stop you from doing this? Or why are you doing this? And how are you being responsible about it? And I think in this particular case, the responsibilities weren't really taken seriously by the person developing the model. And so that's why there was a bunch of, I think, valid criticism.
I thought so, yeah. Given that I wrote an article about all that. And yeah, I guess one kind of subpoint, one of the responses to it was, well, this wasn't research, this was a funny YouTube video, but you could still make the argument that if you're a solo hacker, solo developer, you just build a model, right? You're still a person in society, and we can still criticize you for being unethical and point out that, probably you should have done these differently, and you should not kind of instigate or enable harm. And that relates, another kind of more nuanced aspect, I think, of this was the aspect of having released the model to interact with real people on 4chan. So this was another aspect of the controversy where the model was used to power bots that messaged a bunch over a couple of days and basically interacted with real people who didn't know these were bots, which is kind of more of a nuanced question than just producing hate speech, because they were just emulating the users and kind of producing the same thing as before. But many people still thought that was unethical. So how would you kind of assess that use of the model?
In that context, I think a lot about manipulation and deception of individuals. So if you are interacting with a chatbot and you're made to believe it is human, I think something unethical has happened. I think we need to be more transparent about where technology is used and where it isn't used. And this is partly to protect the individual, right? And their sort of dignity and autonomy. But it's also to protect some kind of broader social institutions, like the fact that now that you and I are talking, I trust I'm talking to a human. If I've experienced a few times that I've been deceived in this way, then there I have a bit more of a disbelief about it. And I think, for example, fake news, we've seen this problem too, where there's this dual kind of harm. So one is, you mislead a particular person and they have a false belief. But the other is that people just become more wary of stuff they read. And that's probably a good thing, because stuff we read on the internet, we often can't verify where it comes from and whether it's true. But it can also be really harmful, where then maybe people, and actually there was a report last year on this, where people trust the news less. And so it can erode this kind of fabric that we have in society to share knowledge and to trust our shared knowledge. So I think this is a problem here.
Yeah, and I think it's easy to sort of take it that seriously because it's 4chan and it's, a bunch of people already spewing hate speech to some extent. But, fundamentally, if you abstract it away, that I think is exactly what you're saying. So, yeah, I think that's a great coverage of kind of a few aspects of your work. And to round things out, as usual, we want to forget about AI for a bit and just acknowledge that we are both human beings. So what are some things you find interesting or you do as hobbies outside of your work?
Yeah, we are humans. No joke about it.
These are not deepfake chatbots talking.
As far as you know, and I know. Yeah, so thanks for the question. What do I do outside of research? So I play the saxophone, alto, and I do enjoy playing jazz badly, and do outdoor rock climbing, which I think is a staple hobby for a lot of people in the sector anyways. But because I'm based in Europe, I probably do it in different places too. the to many of the other tech people. And yeah, I have a lot of different interests. I guess now I'm looking to a period where I'm expecting a kid sometime soon. And so there will be a period where all of this will have to take I'm going to get new hobbies, maybe finger paint, something like that. Let's see what comes.
That is an answer I've gotten a few times of like, what is your interest? Well, I have a 2-year-old kid and that's like life at this point. But yeah, no, that's great. I think often people do say they have some sort of exercise related thing. So for listeners who might think academics are all about thinking and reading, we do try to actually physically do things as well. So take that into account. Well, with that, we can finish up. So that was a really fun interview. Thank you again, Laura, for joining us.
Thank you so much.
All right.